Hello! In this video, I will present the rock cycle to you with my best buddy Augie and our helper Delilah. If you would like to play along, all you need is a handful of play-doh. So pause the video and go get a handful now. Let's get started. First, let's talk about rock types. There are three main rock types in this world: igneous, sedimentary, and metamorphic. Let's start with igneous. Igneous rocks are rocks that form when hot molten magma crystallizes and solidifies or turns to rock. The magma forms deep within the earth and rises to the surface. There are two types of igneous rocks: intrusive igneous rocks and extrusive igneous rocks. Intrusive igneous rocks form when the magma gets stuck inside the earth and cools there. Extrusive igneous rocks form when magma exits through a volcano or a fissure and cools on the surface of the earth. Some igneous rocks you may be familiar with include granite and basalt. Sedimentary rocks are formed from rocks that already exist or pieces of once living organisms that are cemented together and turned to stone. The pieces commonly come from erosional processes, which include water in the form of rain and ice, along with wind and other natural agents. These rocks form on the surface of the earth. The rocks commonly have layers, also called bedding. Some sedimentary rocks you may be familiar with include sandstones, conglomerates, limestones, and shale. Metamorphic rocks are rocks that started out as another rock type but have been changed by high pressure, high heat, hot fluids, or a combination of these factors. Conditions like these are found deep within the earth. Some metamorphic rocks you may be familiar with include marble and quartzite. Now we will review the rock cycle. We will go through it twice. I will walk through it once, and the second time we will mimic the rock cycle with our play-doh. So let's begin. When we think about the rock cycle, we are going to start thinking, well, 4.6 billion years ago. Why? Because that's when the Earth formed as a big ball of hot magma. Then the magma started to cool, making our first rock type. What rock type is this? That's right, igneous. If our magma had cooled underneath the surface of the Earth, what kind of igneous rock would it be? If you said intrusive igneous rock, you would be correct. But for this video, the volcano will erupt and cool at the surface, forming an extrusive igneous rock whose name is Delilah. Now that Delilah is hanging around at the surface of the earth, what are some things that can happen to her? Well, she could get picked up and carried away by a little rock hound. She could be studied by a lava-loving geologist, or she could possibly be picked up, painted, and turned into somebody's pet rock. But if none of those things happen, she will stay there and is bound to get rained on, blown on by the wind, and depending on where she lives, she could even get snowed on and froze. Water, wind, and freezing are some of the agents that break down rock into smaller pieces. This is what we call erosion. We are eroding the rock by breaking it down into smaller pieces. Weathering. Each drop of rain tears down Delilah's surface grain by grain. Delilah's beautiful fractures are made larger by freezing and thawing. When water freezes, does it get bigger or smaller? The answer I normally get is that it gets bigger when it freezes. Water gets bigger or increases its volume when it freezes. So if we have some water that is caught in one of Delilah's fractures and then it freezes, that ice is bigger than the water, and this will put pressure on her fractures, making them bigger. This is called frost wedging, and it causes rocks to break. Wind can carry particles from other rocks. When the wind particles hit Delilah, it sandblasts her, tearing little pieces away from her surface. But she doesn't mind because now she's going on a trip. These broken down pieces of rock can be transported by gravity, wind, or water. For our example, we will use water. So let's say Delilah is eroding very close to a river. Her broken pieces will be swept up by the river and they will be washed away. Where do rivers go? Yes, to lakes or oceans. When the river arrives at a lake or an ocean, the broken pieces of rock will be dropped. Why? Think of a river versus a lake. The river is moving, right? Is the lake moving as much as a river? No, lakes do not move as much as rivers, so they do not have the energy needed to keep the broken pieces in the water. Therefore, the pieces, once they reach the lake, fall out and settle to the bottom of the lake. So now that Delilah is at the bottom of the lake, does the river stop flowing? No, it does not. So, new pieces of rock and debris will continue to fall to the bottom of the lake, burying and squishing Delilah. But don't be sad. This is not the end for Delilah. It's a new beginning. As Delilah is buried, she is squished and compacted. As she is squished and compacted, the pieces of rock begin to get stuck together or cemented. As the water is squished out of the rock and the cementing process completes, Delilah is finally lithified, a fancy word for turned to stone. She is now a brand new rock, a sedimentary rock. Uh-oh, now there's some magma on the loose, and it's headed right towards Delilah. If she is melted, she will ride the rock cycle all over again. But the rock pile Delilah is in appears too tough for the magma to get through, and it stops below her. But she is exposed to lots of heat and pressure. Luckily, Delilah is super tough, and it doesn't hurt her, but rather it changes or metamorphoses her into a new, shiny, metamorphic rock. Do you know of anything else that changes or metamorphoses into something else that's beautiful? Maybe like a caterpillar to a butterfly, for example? Whether Delilah is a sedimentary or metamorphic rock, the adventure doesn't have to stop deep underground. There are geologic forces that can bring her back up to the surface. Once at the surface, she can take another trip on the rock cycle, being eroded, transported, and turned into a sedimentary rock again. And this is the life of a rock, a cycle that has been happening over and over again for billions of years. Now we can mimic a rock going through the rock cycle using some play-doh. Roll the play-doh up in a ball and place it in your hand. Your hand is going to be the volcano, and your volcano is just about to erupt. Lava will flow out of the volcano and cool on the surface of the earth. Go ahead, erupt that volcano. What kind of rock have you just made? An igneous, a metamorphic, or a sedimentary rock? That's right, an igneous rock. But specifically, what kind of igneous rock have you made? Intrusive or extrusive? That's right, an extrusive igneous rock. If our magma would have cooled underground, it would have been an intrusive igneous rock. Now that our extrusive igneous rock is on the surface, what are some things that'll happen to it? That's right. Wind and water will erode our rock, breaking it down into smaller pieces. What do you suppose you're going to do with your extrusive igneous clay rock right now? That's right. Your hands will act like the water and the wind to break the rock into smaller pieces. The pieces can be big, they could be small, they could be rounded, or they could be angular. It doesn't matter. I will be silent for 2 minutes while you take the time to break up your rock. After you are done, place all of your broken pieces into your hand. Your hand will act like the stream. Your hand will transport the pieces of broken rock to the lake, which will be the table or the desk in front of you. Then let the pieces fall on the desk, making a pile of broken rock. Don't squish your pile yet, though. We're not that far along in the rock cycle yet. Our pieces have only just arrived at the lake. So now our rocks are at the bottom of a lake that is fed by a very busy river that is constantly piling new material on top of our rocks. As our rocks are squished and compacted, the pieces will begin to stick together, or our pieces will get cemented together. As all of the water is squished out of our rock and the cementing process completes, our rock will be turned to stone. A brand new, what kind of rock is this? That's right, a sedimentary rock. So go ahead and use your hands to very, very gently cement your rock pile together. Remember, don't squish your rocks too hard. Only squish it enough that the pieces gently stick together. You still want to be able to see those broken pieces of rock that you made. Now, here comes the heat and pressure. But the heat and pressure we will use will be a bit cooler than magma. We are going to use our hands. And what do you think we are going to do? We will squish our rock pile as hard as we can, changing it into what kind of rock? That's right, a metamorphic rock. So go ahead and squish your rocks. This is what our metamorphic rock looked like. Now, you could make your metamorphic rock back into magma and erupt the volcano to start the cycle over again. Or you could lift your metamorphic rock to the surface and erode it and make it into a sedimentary rock again. It's a cycle, so you can use your play-doh to repeat and take different routes in the rock cycle as many times as you like. Now it's time to rock. Let's take a look at some cool rocks. Let's start by looking at some igneous rocks. Here with me today is my helper Augie, and Augie has some, do you remember what kind of rocks? Igneous rocks, right on, buddy. He has some igneous rocks. In his hand, he's holding a lava bomb. A lava bomb. This rock was ejected out of a volcano, and as it flew through the sky, it spiraled like a football, cooling in that shape, and then fell to the ground. Wouldn't want one of those hitting you in your head. The other rocks that Augie has are intrusive igneous rocks. This pink one cooled deep inside the earth, and it is a piece of the Rocky Mountains. The black and white one that Augie's gonna grab is a piece of the Sierra Nevadas. Great job, Augie. Now let's check out some sedimentary rocks. Earlier in the presentation, we talked about how sedimentary rocks have layers, much like the layers you can see in the rock that Augie is holding here, this sandstone. Rocks have layers because when the broken pieces of rock get deposited into a lake, the heavier particles will fall out first, and the very light particles will fall out last. This is our little shake jar here, and what Augie's gonna do is he's gonna shake this jar really, really good. And then we'll come back in a little bit and we'll take a look. So Augie, shake that jar with all your might. There you go, keep shaking. This is something you guys can all try at home too. We're gonna shake, 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 and then we're gonna set it down and we'll come back and check out what happens here in a little bit. Let's bring the heat and pressure with some metamorphic rocks. Hey Augie, I was wondering if you could do me a favor. Could you try to apply some heat and pressure to these two rocks up in front, to our lava bomb and our granite? Maybe try to metamorphose those guys? No, not that one. Let's try that one. Lots of heat and pressure. Pressure, pressure. Oh boy, he's giving it a good shot. But it doesn't look like we've metamorphosed that rock either. But if Augie had superhero powers, he'd be able to apply enough heat and pressure to these rocks to turn them into metamorphic rocks. If we metamorphose a basalt under the right conditions, this basalt will turn into this beautiful shiny piece of blue schist. And if we metamorphose this piece of granite with enough heat and pressure, it would turn into this piece of gneiss, a Gneiss. This piece of gneiss is from Montana, and it is about 4 billion years old. This piece of gneiss also kind of looks like a piece of cake to a lot of people. Always makes me hungry. Do you think you can fold a rock? A question that I normally ask students when I go into the classroom is, would you believe me if I told you you could fold a rock? Well, can you fold a rock?
Nope.
No? Well, we can't fold rocks, but geologic processes can fold rocks. This is a beautiful fold found in a sedimentary rock. I found this out in Eureka, Nevada, one of my favorite rocks. And this guy I found right here in Carson City. And you notice all those little tiny folds running through this rock. This is what happens with heat and pressure. Let's review the rocks you saw using our rock cycle diagram. So here are the rocks we saw placed in their appropriate spot along the rock cycle. We have our granite, which is our intrusive igneous rock, which formed when lava cooled inside of the earth. A lava bomb made from extrusive lava that was shot out of a volcano and cooled on the earth's surface, or in this case, on its way down to the earth's surface. A jar of sediments that came from the erosion or breakdown of other rocks. A sandstone and a chert made from the broken down sediments that have been cemented together and then turned to stone or lithified. And finally, are samples of schist and gneiss that were made when heat and pressure changed or metamorphosed another rock. Let's go back and take a look at what happened in our shake jar. Circling back to our shake jar, if you look, you can see that a lot of our sediments or particles of rock have settled. You can shake this jar over and over again and you will get the same results, with the largest and heaviest particles settling on the bottom or settling out first, and the smaller, lighter sediments settling on the top. This settling is what gives sedimentary rocks their layers or their bedding. So go ahead and give this a try at home. All you need is a jar, some dirt, and some water. Fill the jar about half full of dirt, add some water, put the lid on, and shake it and see what your layers look like. We hope you have enjoyed learning about rocks and the rock cycle, and we thank you for watching. Have a great day.